In this lesson, we're going to talk about inverse of functions. Inverse of functions is just like finding the reciprocal of any given function we have. It's just like when you are given 1 over 2, that the reciprocal of 1 over 2 actually is 2 over 1, or you can just write it as 2. So that's just all about inverse of function, finding the reciprocals of any given function. And then the concept is pretty easy. So in any given function, you just switch y for x, and then we look for a way of making y the subject of the equation. Don't forget the concept, switch y for x, and then make y the subject of the equation. Whatever you obtain as the value of y actually becomes the inverse of your function. Let's take a look at some few examples here. If f of x equal to 2x minus 7, your f of x is actually y. So we can write it as y equal to 2x minus 7. And then the next thing we want to do is to switch y for x in the equation. So this becomes x equal to 2y minus 7. So if you check that step very well, you discover that y has become x and x has become y in the equation. So if x equal to 2y minus 7, we can just write it out as 2y minus 7 equal to x. I'm still basically writing the same thing. But because I'm interested in making y the subject, so I love to write 2y minus 7 in the left-hand side of the equation and move x to the right-hand side of the equation. So it's basically the same thing. But it's more comfortable when you have that on the left hand side of the equation so that you can just make y the subject of the equation. So the next step we want to take here is to move 7 to the other side of equality sign, and that probably becomes 2y equal to x plus 7. That's minus 7 on the other side of equality sign. It will become positive 7 in the other side of equality sign. And then since we have y as the coefficient, 2 as the coefficient of y, so the next thing we want to do here is to divide both sides by the coefficient of y, which is 2. So dividing both sides by the coefficient of y, so it will leave us with y equal to x plus 7 all over 2. And this is basically the inverse of a function. But we've got to use the denotation of the inverse of f of x. And this becomes the inverse of f of x is equal to x plus 7 over 2. Let's take a look at another example here. The concept remains the same in any given functions. In any questions you may want to solve. If f of x equal to x cubed plus 8, so we need to write it as y equal to x cubed plus 8. And don't forget the concept, switch y for x, and then we make y the subject of the equation. So in this case, switching y for x, it becomes x equal to y cubed plus 8. So if you look at the step very well, you discover that y has become x and x has become y. So all we need to do is to look for a way of making y the subject. And as well, we can just write it out as y cubed plus 8 equal to x, and then we'll move 8 to the other side of equality sign. That becomes y cubed equal to x minus 8. And then cube here becomes cube root on the other side of equality sign, and that becomes y equal to cube root of x minus 8. But because we need to use the denotation of the inverse of f of x, so we've got to write it out this way as the inverse of f of x equal to cube root of x minus 8. That is the answer, or that is the reciprocal of the inverse. That's the reciprocal of the f of x we're given. Let's take a look at another question. Here we have f of x equal to square root of x plus 2 minus 5. We need to be conscious of the fact that that minus 5 is not under the square root sign. So we need to be conscious of that by the time we interpret or take the further steps. So let's first of all write f of x as y. And of course, our y becomes square root of x plus 2 minus 5. So if y equal to x square root of x plus 2 minus 5, we want to switch y for x. So y will become x, and this becomes x equal to square root of y plus 2 minus 5. So if you check very well, you will see that y has become x and x has become y. So we want to move 5 to the other side of equality sign, and that becomes x plus 5 equal to square root of y plus 2. And we can just write it out as square root of y plus 2 equal to x plus 5. And then we have a target of making y the subject of the equation, and this equation we have it. And then we have square root of y plus 2. So the only thing we can do is to square both sides, or you move square root sign to the other side of equality sign. And when square root moves to the other side of equality sign, it becomes square of any terms you may have in the other side of equality sign. So in this case, we have y plus 2 equal to x plus 5, all in the bracket square. And then we can just move 2 to the other side of equality sign. That becomes y equal to x plus 5 square minus 2. And then we can choose to open up the bracket of x plus 5 square. And that becomes x plus 5 square minus 2. And then that has become the inverse of our function. So the inverse of our function is x plus 5 square minus 2. Or if we choose to open up the bracket, and that is going to be inverse of function of x squared plus 10x plus 23. So let's take a look at another example. In this case, we have f of x equal to cube root of x plus 4 minus 2. Just like we have in our previous question, that minus 2 is not under the square root of the square root sign, the cube root sign. So we have to be conscious of that fact. So we write this as y equal to cube root of x plus 4 minus 2. And then the next step we want to take is to switch x for y. So here is x equal to cube root of y plus 4 minus 2. And then we move 2 to the other side of equality sign. That becomes x plus 2 equal to cube root of y plus 4. And then we can just write it out as cube root of y plus 4 equal to x plus 2. So in this case, what we need to do is to move cube root to the other side of equality sign, and that will become cube itself. So this becomes y plus 4 equal to x plus 2 cube. And then you move 4 to the other side of equality sign. That becomes y equal to x plus 2 cube minus 4. This is basically the inverse of the given function. But we need to use the denotation of the inverse of f of x, which is equal to x plus 2 cube minus 4. And of course, if you choose to open up the bracket, that's going to give us a cubic polynomial. That's a polynomial of third order there, which is going to be x cubed plus 6x squared plus 12x plus 4. Let's take a look at another example here. In this example, we are given f of x equal to 3x minus 7. So over 4x plus 3. So we just have to write it as y equal to 3x minus 7 over 4x plus 3. So the next thing we want to do is to bring in the techniques, the concept of finding the inverse of function itself, which is switching y for x in the equation. So in this case, we have x equal to 3y minus 7 over 4y plus 3. So if you take a look at it very well, you discover that y has become x and x has become y. So then the next thing is we want to do cross multiplication. So doing cross multiplication, that it brings us to 3y minus 7 equal to x in the bracket 4y plus 3. So we need to use x to open up the bracket there. So we have 3y minus 7 equal to x times 4y, that is 4xy, plus x times 3, that is 3x. So we need to arrange the constant, any terms that has y there together, so that we can make y the subject of the equation. So in this case, we have 3y. When 4xy move to the other side of equality sign, that becomes minus 4xy. And then minus 7 coming to the other side of equality sign as well, that becomes 3x plus 7. So all we need to do here is to make y the subject, and then we need to make use of y to factorize what we have in the left-hand side of the equation. So making use of y to factorize that, we have y in a bracket 3 minus 4x, which is equal to 3x plus 7. And then we've got to divide both sides by the coefficient of y, which is 3 minus 4x. So doing that, that gives us y equal to 3x plus 7 over 3 minus 4x. This is basically or technically the inverse of the given function. But we need to use the denotation of inverse of f of x, and that is going to be 3x plus 7 over 3 minus 4x. That is the answer to such a question. Thanks for watching. Kindly subscribe to my YouTube channel.